page replacement. Okay, so here see we have already seen in the class. Okay, so the FIFO page replacement. So when the page fault basically occurs, the operating system has to select a page to remove from memory to make space for the page that is to be brought in. Okay, so this phenomenon will be called as what? This will be called as the page replacement. So there are various page replacement techniques are there. FIFO page replacement, optimal page replacement, least recently used page replacement, not recently used page replacement. Okay, now so the whatever the basic page replacement is there, so see in the practical basically we are going to implement the first one, that is the FIFO page replacement. Okay, so how the page replacement will be done? See, first we have to find the location of the desired page on the disk. Okay, then find a free frame. Suppose if there is a free frame, then use it. If there is a no free frame, then we have to use a page replacement algorithm, any one of them. Suppose if we are going for the first in first out, so we will use that algorithm to select a particular victim frame, then read the desired page into the newly free frame. Okay, then update the page and the frame table and then restart the process. Okay, so let us start with our first page replacement algorithm that we are going to implement, that is the first in first out. Okay, so about the first in first out, see this one is the simplest page replacement algorithm. Okay, the simplest page replacement algorithm is a first in first out algorithm. So basically in this algorithm, the time when that page was loaded into the memory is considered. Okay, and when the particular page must be replaced, so which particular page we are going to choose? The oldest page will be chosen for the replacement. Okay, and the FIFO queue is used to hold all pages in the memory. Now the page is replaced at the head of the queue. Okay, and when that particular page is brought into the memory, it is inserted at the tail of the queue. Okay, now let us consider the example of the first in first out page replacement algorithm. So here they have given a certain reference string and the frame size is 3. Okay, so first initially there was a 2 that we have to insert, so the frame size is 3. So first page is placed into the particular frame. Next is the 3. Okay, so after the 2, 3 will get placed. Okay, now again next 2 is there, but 2 is already there. Okay, so next we will take it as a 2 3, so here page fault will not occur. Okay, now next is 1 will be placed at the last position over here in the frame. So now it will become the 2 3 1. Okay, now what is the next page that we have to insert? It is a 5. Okay, now to put the 5, okay, we have to replace the oldest page from this. Okay, so among the 2 3 1, the oldest is which one? The oldest is the 2. So the 2 will get replaced. Okay, and 5 will get placed over there. So it will become 5 3 and 1. Okay, now the next page is the 2 is there. Okay, now to place the 2, we will replace the 3. Okay, so it will become the 5 2 and then 1. Okay, then we will place the 4 over here. Okay, so we have to place the 4, to place the particularly 4. So what we will do? We will replace the 1. Okay, and then we will place the 4 over there. So it will be 5 2 and 4. Okay, now the next is 5. So 5 is already there, so it will be as it is. Okay, now we have to place the 3. So we will place the oldest page again from this. The oldest page will be the 5 will get replaced with the 3, so it will become the 3 2 and 4. Okay, now next we have to place the 2. Okay, so 2 already there, so there will be again no page fault. Next is 5. So to place this particular 5, now the oldest page among this will be the 2. Okay, so 2 will get replaced with the particular 5 and it will become the 3, 5 and 4. Okay, next is 2. Now to place the 2, we will replace the 4 and then we will place the 2 over there, so it will become the 3, 5 and 2. Okay, so now we will count the total number of page faults over here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So the total number of page faults here will be the 9. Okay, now this is one of the example for FIFO page replacement. Again we will consider now the second example. Okay, now in the second example, the reference string is again given and here the frame size is considered as a 3. Okay, so here 7 is there. First we will insert the 7, then 0, then we will insert the 0. Page fault will occur. Here also page fault will occur. Next is 1. So at the third position we will insert the 1. So it will become the 7, 0 and 1. Now we have to place the 2. Now where to place the 2? So to place the 2, again we will choose the oldest page among this. So now oldest one will be the 7. So we will replace the we will replace this 7 and then we will put 2 over there. So it will become the 201. So page fault will be there. Next page is the 0. 0 is already there, so no page fault, it will be as it is. Next is 3. Okay, now next 3. So 0 will get replaced and 3 will be get placed over there. So it will become the 2, 3 and 1 page fault will be there. Next is the 0. Okay, so here 2, 3. Okay, so 1 will get replaced and 0 will get placed over there. Now to place the 4, 2 will get replaced and 4 will get placed over there. So it will become the 4, 3 and 0. To place the 2, okay, 3 will get replaced and 2 will get placed over there. So it will become the 4, 2 and 0. To replace the 3, 0 will get replaced and 3 will get placed over there. Now to place the 0, again 4 will get replaced and 0 will get placed over there. So it will become the 0, 2, 3. We have to place now 3, but 3 is already there. So there will be the no page fault. It will be as it is. Now next we have to place the 2. Okay. Now to place the 2. So here 2 is already there. So there will be the no page fault. To place the 1, see now oldest among this will be again 2. So 2 will get replaced and 1 will get placed over there. So it will become the 0, 1 and 3. Okay. Now next is the 2. So to place the 2, we will replace the 3. So it will become the 0, 1, 2. Okay. Now to place the 0, 0 is already there. So it will be as it is. To place the 1, 1 is already there. So it will be as it is. To place the 7, now 0 will be the oldest among these. So 0 will get replaced and 7 will get placed over there. Okay. Now next is 1. Okay. 2. Okay, 7, 1, 2, it is become the 7, 1, 2, page fault will be there. To place the 0, now we will replace the 1, okay, and place the 0 over there. So it will become the 7, 0 and 2. Okay, here actually it's 1, not 9. Okay, so here it should be 7, 0, 1, page fault will be there. So now we will count the total number of the page faults. So it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Okay. So there will be the 15 page fault will be there. So see here, for our this particular example reference string, our 3 frames are initially empty. So first 3 references, okay, here the 7, 0 and 1. So cause the page fault and are brought into these empty frames. Again the next reference was the 2. Okay, after the 1 there is a 2. So it replaces the page 7 because page 7 was brought in the first and that was the oldest. Okay. Now the next reference is 0. We can see the next reference is 0. Okay, and 0 is already there in a memory, so there is no page fault here. Okay, 0 is already see 701, then 2, okay, then 0. So that was 0 was already there, so for placing this 0 there will be the no page fault. Okay, now the next reference will be the 3. Okay, now to which is to be replaced with the 0. Okay, and it was brought before 2. See here, to place the particular 3. Okay, so we will replace the 0 over there and then we will place the 3 over there. Okay, so likewise all the things we are doing, and then finally we are calculating the page fault. So page fault, it comes to the 15. Okay, then the FIFO page replacement algorithm is basically easy to understand and the program also. So but its performance is not always good, but it increases the rate of the page fault. Okay, now what exactly we want in the then output for this particular algorithm? See, first we will ask what the total number of pages we want. Okay, suppose we want the total number of the pages as a 20. Okay, then enter the page numbers. So after that, whatever the page numbers are there, that we will enter. Okay, then they will ask, or we ask about the enter the number of frames, how much frame size is want. Okay, we want 3 or 4 like that. Okay, suppose we take it 3. Okay, and likewise see, we'll get the output, and finally we are calculating the page fault. Okay, so it is about the presentation. Now I will show you the practical demonstration of this. See, now here there is a program is there. Okay, so in the see, in the particular program here, initialization first, see, we are making a C code. Okay, for the FIFO page replacement. Okay, so here we have taken the online C compiler to run the particular program. So initialization here we have done, then enter the number of the pages, we are taking that into the n. Okay, then page number, so we have put loop over there. Okay, and into the AI we have taken the array for taking those particular page numbers, so all those will go into the AI. Okay, and here we have taken the loop for that. Then next is the number of frames, how many frames we want, either 3 or 4, so we are scanning that into the NO number. Okay, then here we'll put the loop. See here, see, when first we put na 7 only there, then remaining 2, we can say that particular frame columns will be the empty, so there we will put the -1, frame I is equal to the -1. Then j is equal to 0. Okay, reference string, just we are giving the labeling, so whatever initially the pages that we are inserting, so we will label them as a reference string, and then remaining as a page frames. Okay, whenever we will enter those particular pages into the frame, we'll call it as the page frames. Okay, then next is we are taking the loop. Okay, so a of I. Okay, so whatever the, we can say, page numbers will be there, that into the a of I. See, now if available of 0. Okay, so see here again we are taking the loop. Okay, and see here we are taking it is into the frame k to check whether those particular we can say pages are present into that particular frame or not. See, if available of 1 is there, then it will be as it is. Okay, we are not inserting any new page over there. But if available of is 0, okay, then we will move into the particular loop. Okay, so a of I, that particular page will get placed in the frame of j. Okay, and then again the will check. Okay, so remaining we can say to insert the particular pages into the remaining frame, so we are calculating this modulus. Okay, and here basically we are putting the counter, so that count will tell us now how many particular page faults will be there. Okay, into the that particular we can say whole page list. Okay, so how many pages will be placed over there. So this for that here we are making the counter. Okay, then frame k, so it will be print the those particular new frame k. So whatever the new pages we are inserting, so here we are printing that printf slash n, and here basically we are calculating the page fault. Okay, so here count whatever we are getting, that will show us the total number of the page fault. Okay, so this is such a kind of the simple algorithm. See, it's like you can make your logic also. Okay, so it is not like that you have to run only this kind of the program. Okay, just what we want the proper output for this. Okay, now let us run this particular program. Okay, so first he will ask about the enter the number of the pages. Okay, suppose see, in our program we have taken the same, we will take the here also. Okay, so the total number of the pages will be the 20. Okay, so here we will put it as a 20. Okay, then enter. So after that we have to insert the page number. Okay, so we will put the page number over here. So see here, so it is like 7012 first. Okay, so here first we will enter the 7, then enter. Okay, then 0. Okay, then enter, then 1, enter. Okay, then 2. Okay, then enter 7012. Okay, then I guess 0. Okay, then enter 3, enter 0, enter 4. Okay, then 0 3 0 4, then 2. Okay, then 3, then 0. Okay, then 3. Okay, then 2, enter, then 1, then 2. Okay, then 0. Okay, we are entering all the 20 pages over there. Then 1. Okay, 7, then 0, then 1. Okay, so likewise we have put on all the 20 pages over there. Now here we have to insert the number of frames. Okay, so the number of frames is the 3. Okay, now see, we have calculated the page fault for the same, so it comes to the 15. Now we'll see the output. See here. Okay, so see, actually reference string it is here, it should be here only, reference string, and these are nothing but the page frame. So initially we are inserting the 7. Okay, and rest of the things are the -1, nothing was there. Okay, now next is 0, so 7 and then 0 will get placed. Now here nothing is there, so that's why -1. Then 1, so 7 0 1. Now to place the 2, we have to remove the particular oldest page, that is the 7 from here. Okay, so it will become the 2 0 and 1. Okay, now next is 2 0 and 1. Okay, now here next is 0, but 0 is already there. Okay, so available is, if already is there, available of 1, available is equal to 1 is there, so we will not go into the loop. Okay, it will be the as it is. Okay, so likewise these particular all the pages will get placed. Okay, and then we will count is page fault if we start the counting like 1 2 3 4 5 6 7. Okay, 7 up to the 430. Okay, then 420 423 023. Okay, okay, so it's like will when we go to 0 to 4 3. Okay, so likewise when we count now, the count comes to the 15. Okay, so the page fault for this particular example, it comes to be the 15. Okay, so likewise we have seen actually its actual example also. Okay, in the presentation. So likewise this particular algorithm will work. So that is about our page replacement algorithm. So you have to execute the same program. Okay, and see the how the output will come. You can take the different, you can say different example also. Okay, and check whether first solve it and check in the program also. Okay, so your page fault rate must match over there. Okay, so that is about our FIFO page replacement. So thank you so much.